All right. So, did not realize that my video cut me off right at 30 minutes, which is fine, but I didn't know it had been 30 minutes. I have no concept of time right now. So, let's just look at, I went ahead and did some questions and we'll just talk about them. So, I ended on number 9. First step for solving a system using substitution, you're going to solve an equation for one of your variables. For 10, you're going to multiply the equation by a number so that a variable can be canceled. So that's your first step for elimination. Number 11, so with substitution, I'm just going to explain what I did instead of rework it. We have y equals something. We're going to take what y equals, plug it in for y into the other equation, and that gives us this. So we have 2x, and instead of this y, we put in the x plus 4, so that's that here, equals negative 5. All right, and then, so I combined like terms to get 3x. I subtracted 4 to cancel. We're left with 3x equals negative 9. We divide both sides by 3, and we're left with x equals negative 3. Then we took this x equals negative 3, came back up to this equation. You can choose either equation. It's up to you. But I chose this equation because it's a little easier. And instead of x, we substituted negative 3. So now we have y equals negative 3 plus 4. And negative 3 plus 4 is 1. So we have 1 for y, and we have negative 3 for x. So when we come here, you can always verify your answers with Desmos. We have 2x plus y equals negative 5. And then we have, over here, we're going to have y equals x plus 4. And this is their point of intersection, negative 3, 1, which is what we got. We had x is negative 3. X is negative 3. Y is 1. We need our solution as an ordered pair. So that is negative 3, 1. Okay. So I'm going to try to move a little bit faster so that I don't get cut off a second time. Number 12, we want to show the first step in order to solve this system using substitution. Well, we already have y solved here, and we're going to plug it in up here. So we have 5x plus, instead of y, we're going to put in x plus 3 equals negative 3. All right, so here's where we substituted. We're going to combine like terms. 5x plus x is 6x. And then we have a plus 3 equals negative 3. We're going to subtract the 3 from each side. These cancel, and I'm left with 6x equals negative 6. We're going to divide both sides by 6. And x equals negative 6 divided by 6 is negative 1. All right, so there we have it. We have negative 1 for x. Now we're not finished yet. We have our x, but we also need our y. So I'm going to come back up here. And you can choose to plug negative 1 into either equation, but this looks a little bit easier. So we have y equals, instead of x, we're going to plug in negative 1 plus 3. And negative 1 plus 3 should be 2. All right. So here we go. We have negative 1 and positive 2. Oh my goodness. We have negative 1 and positive 2. As our ordered pair, we're going to verify that with Desmos. Again, you can always check by substitution. You can plug in your equations, plug in your ordered pair into your two equations and verify that it's a solution. It's 5x plus y equals negative 3. But if you have Desmos, use Desmos to verify. and y equals x plus 3. And here I have negative 1, 2, which is what I have here. So that is the solution. Okay, 13. We're going to solve using elimination. And we're going to express our answer as an ordered pair. Okay. So elimination, we want to eliminate a variable. So we have 4x minus 2y equals 28. Negative 2x plus 2y equals negative 12. So the beautiful thing about elimination is if they are set up pretty like this, you can just eliminate a variable by adding or subtracting. We have a negative 2y and a positive 2y. Those will cancel out. We're going to just add everything else together. So 4x plus negative 2x is a positive 2x. 28 minus 12 brings me to 16. To solve for x, I'm going to divide both sides by 2. X equals 16 divided by 2 is 8. Okay. I was about to graph, but I'm not ready for that yet. Okay, now that I have the x is 8, I'm going to come back to one of my equations. Doesn't matter which one, and we're going to plug 8 in for x. I think I'm going to go to the bottom one just because I'd be multiplying by 2, and even though it's negative, I think that's going to be a little easier on my brain. Filming this right before we get out for fall break, so of course my brain is a little bit on the fried side. Okay, so we have negative 2x. This x is, we're going to put 8 here, plus 2y, we don't know what y is, equals negative 12. Negative 2 times 8 is negative 16. 2 plus 2y equals negative 12. We'll add 16 to each side. These cancel, and I'm left with 2y equals 16 minus 12 is 4. I don't know why that took me so long. Divide both sides by 2, and y should equal 2. Okay. Let's just verify with Desmos. For x minus 2y equals 28. Negative 2x plus 2y equals negative 12. And our 8-2 is our 8-2 is our solution. Okay. All right. So, and write as an ordered pair, so this would be 8-2. Whew, it's getting messy. All right, number 14, a variable needs to be eliminated to solve the system. What is the first step? So if we look, we have an x and a 2x, and we have a 3y and a 3y. So these both have the same coefficient. They both have a 3. So I can cancel them by subtracting. So if I do 3 minus 3, it cancels, and I will eliminate y. So our answer is C, subtract to eliminate y. All right. Okay. All right, so let's look at 15 and 16. So these say solve using any method. So you could do substitution, you could do elimination, you could do graphing. So for the sake of time, because these videos get super long, I'm going to graph both of these on Desmos and give you the solution. You are so welcome to use substitution or elimination. So what I would recommend you do now is to pause the video and then come back and check your work and make sure that we all got the same thing. Okay, so I'm just going to graph using Desmos. If you want to use substitution or elimination, go for it. Just pause it and check your answers. So y equals negative 8x plus 5. And then 8x plus y equals negative 7. So just for just to be transparent, what I would have done is I probably would have used substitution, because we've got y is equal to 8x plus 5. And we could have plugged that in easily, but I want to show you something. If you look at my graph over here, these lines are parallel. Okay? These lines are parallel. So I don't even want it. Let's see. We have it negative 7. And what's my slope? Whoo! What slope is it? Oh gosh. Oh, it's 8, isn't it? That was, yeah. Whew, that would have been a pain to graph, but these are parallel. So we're going to put no solution. Lines are parallel. I haven't taught y'all this yet. This is the symbol for parallel. It's 2 little slashes, and that way you don't have to write the word parallel every single time. If we were to do substitution and I were to take all of this and plug it into here, what would happen is you have 8x plus negative 8x plus 5 equals negative 7. These would cancel. You'd be left with 5 equals negative 7, which, for an equation has no solution. All right, so these have no points in common. All right, so let's look at the second one, or I guess number 16. Fulfilling, these are going to be infinite. Yeah, and it's going to make sense when we substitute too. So we're going to do negative 2x minus 6. And our bottom equation is negative 2x minus y minus 6 equals 0. All right, so if you look, I don't know if you can see, but the red line and the black line are on top of each other. So if I turn the red line off, all we have is the black line. And then, boom, boom. So these are the same line, just graphed on top of each other. Okay, and those are called coinciding lines. So this is infinite solutions. Coinciding lines. I probably didn't spell that correctly, but it's a good thing I teach math. And just to kind of show what would happen with substitution, if I were to take this and plug that in for y, we would have negative 2x minus, because that is a minus y, and then negative 2x minus 6, and then we have this minus 6 equals 0. This negative would change the signs of everything in parentheses. So we have negative 2x plus 6 minus 6 equals 0. These cancel, and we're left with 0 equals 0, which gives us infinite solutions. All right, so let's see what we have next. So that is the end of page 2. We are done with 16 of these problems. And let's go on to 17. Again, using some Desmos. Desmos is going to make your life easy on this test. All right. So, we have Saving Stella. Is putting money into two savings accounts. Let X represent the number of months. So I'm going to highlight that. X is the number of months. And Y is the balance. Account A started with $225 and account B started with $350. So I'm looking at, we're going to have to fix these. Let's cross these out. I'm going to fix this before I print these. So account A started with $225, and in account A we deposit $15 a month. Oops, let's see, Y equals, and this is for account A. Account B, we started with $350, but we only deposit $10 each month. Okay, here's the system. After a certain number of months, the account will have the same balance. What is that balance? So we're going to set these two equal to each other because they're both equal to Y. We have 225 plus 15x equals 350 plus 10x. We're going to subtract 225 from each side. And I have 15x equals 350 plus 10x. Oh, not 350. Whatever 350 minus 225 is. All right. 350 minus 225 is 125. All right, then we'll subtract 10x from each side. We have 5x equals 125. We'll divide both sides by 5, and x is equal to 25. X is the number of months. So after 25 months, they'll have the same balance. So we're going to plug 25 in for x on both of these. We have 225 plus 15 times 25, and we have 350 plus 10 times 25. Too many numbers. So 25 times 15 plus 225 is $600. 10 times 25 plus 350 is also $600. So at 25 months, both accounts will have $600. And how do you check your work? You use Desmos. I'm going to skip that piece for now, though, and let y'all do that on your own whenever you feel like it. All right, Bell Chic is having a sale on all shirts and pants in the store. Cassidy purchased 4 shirts and 7 pairs of pants, so I'm going to highlight these 4 shirts and 7 pairs of pants for $235. Kyron purchased 5 shirts and 4 pairs of pants for $175. Highlight both of the totals too. Let X represent the price of a shirt and Y represent the price of a pair of pants. Write a system of equations and use elimination, substitution, or graphing. Okay, so let's get this set up. So for Cassidy, she did 4 shirts, and shirts is represented by X, plus 7Y for our pants equals $235. Kyron did the same. He had 5 shirts, 4 pants, and spent $175. All right. So we can use substitution, elimination, or graphing. Again, this is one of those, I don't mind which method you use. I'm going to use Desmos to be quick about it because, again, this is all just practice of the same thing. So 4x plus 7y equals 235. And then 5x plus 4y equals 175. Okay, obviously we cannot see this, but that's okay. I'm going to zoom out. They intersect at 1525. That is my ordered pair. This would be my X, this would be my Y. So shirts cost $15 and pants cost $25. Again, you can substitute, you can eliminate, you can graph. I don't mind whichever one you want to do. So shirts are 15, pants are 25. All right, 19. The perimeter of a wheat field is 640 yards. The length of the field is 3 times the width. So, they've already given us the system. So the system represents the situation. L is the length, and W is the width. What does this point of intersection mean? So let's think about this. We have 2L plus 2W equals 640. So this is the perimeter. Okay. The length of the field is 3 times the width. Okay, that just gives us one of the dimensions. So our point of intersection, so we have this represents the perimeter, this represents the relationship between length and width. So what this gives us is the actual dimensions of the wheat field. So the wheat field is, let's see, 80 yards wide. And 240 yards long. So the good thing was this one didn't really require any math. It's just interpreting the solution. All right, let's see. That is the end of page 19. I'm probably close to my second 30-minute mark. So let's see. I'm probably going to stop my recording here, and then we'll do 20 through the constructive response, hopefully in one video. Thank you so much, and I'll see you in part 3.